Welcome back, 10th class. In the previous session, we studied what a chemical reaction is, and we learned that a chemical reaction is represented with the help of chemical equations, which is the shortest representation of a chemical reaction with the help of symbols of elements and state symbols. The previous session, we had started with certain examples of chemical changes. Can you recall those examples? Can you tell the difference between the chemical reactions of those examples? So, in this session, we'll study about these different types of chemical reactions. There are five types of reactions, which are combination reaction, decomposition reactions, displacement reactions, double displacement reactions, and oxidation reduction reactions or redox reactions. So we'll start with this one by one. The first is combination reactions. In this, two or more reactants combine to form a single product. Let us take some examples. Carbon in the form of coal burns in air to give carbon dioxide gas. Hydrogen gas combined with chlorine gas to form HCl gas. Magnesium ribbon burns in oxygen or air to form magnesium oxide. Calcium oxide or quicklime combine when added in water to produce calcium hydroxide or slaked lime. Second is decomposition reaction. In this one, reactant break down to form two or more products. There are basically three types of decomposition reactions: thermal decomposition, electrical decomposition, and photochemical decomposition reactions. These are some of the examples of decomposition reactions. Let's talk in detail about their types now. The first is thermal decomposition, in which reactant is broken down into two or more products on heating. When green colored crystals of iron sulfate is burned in a boiling tube, we can see the gradual change in color of crystal from green to white and then to reddish brown iron oxide. On wafting the gas towards nose, we can smell oxides of sulfur as burning sulfur. Similarly, when copper carbonate is heated in boiling tube, it changes to black colored copper oxide while releasing carbon dioxide gas. When lead nitrate is heated in boiling tube, it changes to yellow colored lead oxide with the evolution of reddish brown nitrogen dioxide gas. The second type is electrolytic decomposition, in which a single reactant is broken down into two or more products with the help of electricity. Let us talk about electrical decomposition of water using an electrolytic tank. In this, water gets split into hydrogen gas and oxygen gas at different electrodes, that is, hydrogen at electrode, negative electrode or cathode, and oxygen at positive electrode or anode. In this diagram, we can see that hydrogen gas produced at cathode is double the amount of oxygen produced at anode. This is because in a water molecule, there are two hydrogen molecules combining with one molecule of oxygen. Third is photolytic decomposition, in which energy in the form of sunlight is used to break down a reactant into two or more products. For example, when white colored salt of silver chloride is exposed to sunlight, it breaks down to gray colored silver and chlorine gas is liberated. Photolytic reactions are used in black and white photography. In decomposition reaction, energy is used in the form of heat, electricity, and light. Hence, decomposition reactions are also called as endothermic reactions. Next is displacement reactions. In this type, the most reactive element displaces the least reactive element from its salt. Let's look at some of the examples, like when zinc reacts with HCl, zinc displaces hydrogen and form zinc chloride and hydrogen gas is produced. When sodium reacts with water, sodium metal displaces hydrogen and forms sodium hydroxide and hydrogen gas is liberated. Zinc, when reacting with copper sulfate, it displaces copper from its salt and forms zinc sulfate, and copper is displaced. When chlorine reacts with sodium bromide, chlorine will displace bromine and will form sodium chloride, and bromine gas is liberated. Take a look at this diagram. When you put iron nail into copper sulfate solution, which is blue in color, after some times it is observed that blue color changes to green and there is deposition of copper over iron nail. So this is the example of displacement reaction in which iron, being highly reactive than copper, displaces it from its salt. This is the reactivity series according to which we can predict the product formed in a displacement reaction. Take a look at these beakers A, B, C, D and E. In beaker A, copper sulfate and zinc granules are added. In copper sulfate solution, iron nail is added. In beaker C, in zinc sulfate solution, copper tunings are added. In beaker D, iron sulfate solution, copper tunings are added. And in beaker E, in zinc sulfate solution, iron nails are added. We'll keep these beakers for some times and we'll look at the change later. After some times, it is observed that in beaker A, the blue color of copper sulfate solution has disappeared and there is deposition of copper metal under the beaker. In beaker B, the copper here also has been displaced by iron to form green colored solution of iron sulfate, and copper tunings have settled down. In beaker C, we cannot see any change there because copper is not able to displace zinc from zinc sulfate, as copper is least reactive than zinc. In D, iron sulfate solution is also, the color of iron sulfate solution has also not changed because copper is also least reactive than iron, so hence there is no change. And in beaker E also there is no change because iron is not able to displace zinc from zinc sulfate solution. In a double displacement reaction, the anions and the cations of two ionic compounds interchange to form two new ionic products. So we can say that double displacement reactions are in which two ionic compounds exchange their cations and anions. For example, when copper sulfate and sodium hydroxide solutions are mixed, copper hydroxide and sodium sulfate is formed. Take a look at some of the examples of double displacement reactions. There are special cases of double displacement reactions, like neutralization reaction in which acid and base react to form salt and water. Another is precipitation reaction in which one of the products formed is insoluble in water and hence give characteristic color. For example, potassium iodide solution reacts with lead nitrate solution producing a yellow precipitate of lead iodide and potassium nitrate solution is formed. When aqueous solution of barium chloride is mixed with aqueous solution of sodium sulfate, then white precipitates of barium sulfate are formed with sodium chloride which is soluble in water. A combustion reaction is an exothermic reaction in which a compound combines with oxygen to form one or more oxides with the release of energy. Addition of quicklime or calcium oxide in water to form slaked lime or calcium hydroxide is also a type of exothermic reaction as heat is released with the formation of product which can be felt by touching the beaker. The last is the redox reactions, which is oxidation and reduction reactions. A compound is said to be oxidized when it gains oxygen and loses hydrogen. When a compound gains hydrogen and loses oxygen, it is said to be reduced. Let us look at this reaction of carbon dioxide gas with hydrogen gas to form carbon monoxide gas and water vapors. Carbon dioxide has loosed its one oxygen to form carbon monoxide, hence we say that carbon dioxide is reduced. Similarly, hydrogen gas gains oxygen to form water, hence we say that hydrogen is oxidized. In next example, where black colored copper oxide reacts with hydrogen gas to form brown copper metal with the evolution of water vapor. Here, copper oxide loses oxygen to form copper, hence we say that copper oxide has reduced, so reduction has taken place. Whereas hydrogen gas gains oxygen to form water, so we say that hydrogen gas has oxidized, so oxidation has taken place. Similarly, when hydrogen gas is passed over reddish brown iron oxide, it forms grey colored iron and water vapors. Can you tell me that which reactant has reduced and which reactant has oxidized? As iron oxide loses oxygen, it is reduced, and hydrogen gains oxygen, it has been oxidized. Now take a look at some more examples and predict which reactant has been reduced and which has been oxidized. I would like to wait for the answers from you in the doubt clearing session. Now we will discuss about the effect of oxidation in our daily life. There are two main effects of oxidation, that is corrosion and rancidity. Corrosion means eating away of metal slowly by the action of air. There are different kinds of corrosion. Rusting of iron, which is the slow conversion of iron into its oxide in the presence of moisture and oxygen. The number of water molecules in rust varies. Tarnishing of silver. Silver reacts with hydrogen sulfide to form hydrated silver sulfide, which causes silver to develop a black coating. And tarnishing of copper. Copper is attacked by moisture, oxygen, and carbon dioxide to form green colored hydrated copper carbonate. Aluminium is also a reactive metal which reacts with oxygen to form a sticky coating of aluminium oxide, which is unaffected by water, so it prevents further corrosion. Corrosion of automobiles causes millions of dollars of damage every year. Which parts of automobiles corrode most? How can car owner reduce the effect of corrosion? So we can prevent corrosion by covering the surface with a more reactive metal or its oxide. For example, galvanization, which is the covering of zinc metal over a least reactive metal, for example, iron. Tinning, covering the iron metal with tin. Anodizing, which is the covering of aluminium or magnesium, which is made the anode with thick coating of its oxide. Another major effect of oxidation is rancidity. It is used to describe the spoilage of fats and oils with action of oxygen to form aldehydes and ketones, which is responsible for bad flavor and unpleasant smell. The reaction of rancidity is accelerated by heat, light, and traces of metals like copper and iron. Take a look at the color of a fresh oil drop and rancid oil drop. And of course, the smell and taste of rancid oil will be very unpleasant. You must have also observed the color change and smell of rancid fruits as well. Now, what are the ways of minimizing the rate of rancidity? Packaging of food in opaque and colored glass bottles, airtight packaging, and vacuum packaging with inert gases like nitrogen will minimize the rate of rancidity. Next is storage of food in refrigerators or in the dark room and storing them away from moisture. The last is using of organic acids or antioxidants and their salts, for example, benzoic acid and sodium benzoate. So, this was all in this chapter. Thank you, class.